Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 22, 2025, which was about 5 days ago. The big idea is a two-stage system that fuses image and video diffusion to turn coarse 3D geometry plus a camera path and a single-style image into a high-fidelity, consistent video, with results that beat baselines, including a PSNR of 16.74. The paper is titled VideoFrom3D, 3D Scene Video Generation via Complementary Image and Video Diffusion Models. And, as we will see later, the results are really impressive. In short, this paper pairs anchor frames from an image model with geometry-guided in-betweening from a video model to deliver structure-faithful, style-match sequences without needing paired 3D datasets. Alright, the introduction just sketched the two-stage idea. Figure 1 lays out the end-to-end workflow, which starts from coarse geometry with placed assets and then specifies a camera path. The small inset sets visual style using a single reference image. The bottom film strip illustrates the synthesized video, which stays faithful to scene structure and camera motion while maintaining style consistency, even capturing challenging effects like rising steam. Well, Figure 1 showed the end-to-end pipeline. Figure 2 shows why splitting image and video roles matters. The left panel with Stable Diffusion 3T2i produces crisp bricks, clean window frames, and strong contrast. The right panel with COG Video XT2 volts looks muddier, with smeared textures and inconsistent windows, which signals weaker spatial fidelity. These quality gaps motivate using image diffusion for anchors and video diffusion only for in-betweening. So Figure 2 highlighted weaker per-frame fidelity from video models. Table 1 quantifies that gap. Table 1 compares aesthetics and quality across 1,000 samples using CLIPA and MUSIQ, which score image appeal and perceptual quality. Stable Diffusion 3 at 2B scores about 5.94 CLIPA and 67 MUSIQ. COG Video X at 2B and 5B reach around 5.12 to 5.14 and 56 to 58, since only the first video frame is assessed. So, while Table 1 quantified the fidelity gap, Figure 3 shows the full pipeline that addresses it. The left panel performs pre-processing that extracts structural edges and optical flows, which are pixel motion estimates from the geometry and the camera path. The middle panel, the SAG stage, turns edges and a style reference into high-quality start and end views. The right panel, the GGI stage, uses those anchors plus warped noise and edges to interpolate a temporally consistent video. Alright, the previous figure detailed the pipeline. Figure 10 presents qualitative comparisons across methods. The top row shows ground truth structure frames that define the coarse geometry. The left block contrasts outdoor sequences, where SAG and GGI keep facade layout and window spacing stable, while depth-conditioned image to video and vase introduce smearing and drift. The right block covers indoor scenes, which stay temporally coherent under SAG and GGI, whereas baselines blur textures and misalign doors and fixtures. These side-by-sides highlight stronger structure faithfulness and reduced artifacts. So, Figure 10 highlighted visual advantages. Table 2 reports quantitative comparisons across metrics. The SAG plus GGI method leads visual fidelity with PSNR about 16.7, SSIM 0.554, and the lowest LPIPS around 0.236. Structural fidelity improves with PSNRD near 19.8, and perceptual quality peaks with CLIPA about 6.73 and MUSIQ about 68.6. Style consistency also tops the chart, with SC about 0.891 and BC about 0.942, alongside strong CLIPI at 0.840. So Table 2 reported strong numbers. Figure 13 illustrates why the two-stage design matters. The top row with SAG plus GGI stays smooth across time, which signals stable geometry and motion. The bottom row with SAG only exhibits banding and temporal jitter. The red boxes mark severe flickering in facade textures, and the yellow arrow highlights accumulated warping across the tree region as frames progress. Okay. Two takeaways stand out. First, the split design anchor views from an image model, plus geometry guided in-betweening from a video model, delivers structure-faithful, style-consistent videos that beat competing systems. Second, using edges, optical flow, and lightweight LoRa lets creators iterate from coarse scenes without paired 3D data. Broader impact includes faster previews and stylized walkthroughs, with real-time still a stretch. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.